This is video 4 of Unit 1, and in this unit, or in this video, we'll talk about something called significant figures. Now, it turns out that in science, the numbers that you take and work with have to be treated in a special way, unlike math. Because our numbers come from the laboratory, we have to consider significant digits, and it'll make more sense as we go along. Now, there are 5 rules we'll go through that decide which numbers are significant and which numbers are not. So, rule number 1 says that all non-zero numbers are significant, which means anything that's not a 0, so an 8, a 5, a 3. So all 3 of these are actually significant, which means here we have 3 significant numbers. Rule number 2 through 5 will actually concern zeros. So from now on, we'll just decide some zeros are significant, some are not, and we'll go through these rules to decide. Rule number 2 says that zeros between significant figures are significant. So in this case, these 2 zeros are actually between 2 numbers, the 6 and the 5, which means they are significant. Overall, we have 4 significant figures in this number. Rule number 3 says that all final zeros past the decimal point are significant. So final zeros meaning that you have numbers, and then you have a decimal point, and then you have zeros. These zeros are significant because they follow a decimal point and a number. So this is like saying my measurement is exactly 24.00. The reason why you would mention these zeros is because you know the measurement this far out. So again, overall, here you have 4 significant figures. Rule number 4 says that zeros used in front of numbers are not significant. So this is the first time we see a 0 not being significant. So these right here, these 3 zeros in front of the 3 and the 4 are not significant because they are simply placeholders. It just tells us we have a really small number, but they are not part of the significance of the measurement. So overall, in this example, we only have 2 significant figures. Just the 3 and the 4 are significant. And then finally, rule number 5 says zeros at end of numbers without decimals are also not significant. So think of this example. These 2 zeros are not significant because there is no decimal place. So we're saying it's about 8,500 is what we're saying. Now, the real answer could be 8,520, 8,545. Because we don't know these zeros precisely, they are not considered significant. Now, if you were to put or place a decimal place somewhere in here, whether here, or if you were to put the decimal place at the end, automatically that makes these zeros significant. So because there is no decimal place, we only have 2 significant figures in this case, just the 8 and the 5. Those are the rules. Let's go ahead and try to apply the rules to do some example problems. So here is the question. How many significant figures in these numbers? So because all 4 of these are not zeros, we've got 4 are significant. That one's easy. Rule number 2, because this 0 is sandwiched between 2 non-zero numbers, it is significant. So in this case, we have 3 significant figures. With the next example, we have zeros in front. Remember, zeros in front of numbers are not significant because these 4 zeros are not significant because they come in front of numbers. These 2 numbers are, we have a total of 2. And then number 4, we have a 0 after a decimal after a number. It's called the final 0. Final zeros are significant. So because all non-zero numbers are significant, here we have 3 significant figures. And finally, this last number, because there is no decimal point, notice there's no decimal point, this 0 is not significant. The first 2 numbers are still significant, so we get a total of 2 significant figures. So hopefully that made sense. Go ahead and try the same thing on your own. This is practice problem 3. Go ahead and stop the video, do this on your own so you can practice. And then we'll finish talking about multiplication and division. So anytime we put numbers together, we also have to follow special rules. And there's going to be a rule about multiplication and division, and then a rule about addition and subtraction. Let's take a look at multiplication and division first. The rule says that we report the answer in the least number of starting significant figures. So the idea here is that your final answer can't be any more accurate than your worst measurement. So let's count how many significant figures we have in this first number. So since we have 4 significant figures, notice all 4 of these numbers are significant. In the second example, we have only 3 significant figures. So when we combine them together, either through division or multiplication, this could have been multiplication, we go by the least. So we actually go by 3. So notice our answer, even though our answer is written out with many numbers, in math you can keep these numbers here. In science you cannot. You actually have to stop right here. You have to get rid of the rest of these numbers because our numbers have to follow special rules since the numbers came from the laboratory. Now you'll notice that the 1 actually becomes a 2, and we'll talk about rounding here in a minute. But notice we have 3 significant figures because we go by the least. 3 was the least. That's when you multiply or divide. When you add or subtract, a similar rule takes place. Here it says you report the answer to the least number of decimal places. So it's still the least. You go by the least. In other words, your final answer can't be any better than your worst measurement. But in this case, you go and look at the decimal place. So if you take a look at this first number has 1 decimal place. So just 1 decimal place. We can put a 1 if you want below it, just to remind us. The second number has 3 decimal places, and the third number has 2 decimal places. Now, what you do is you decide to go by the least. So the least is 1, which means our answer should only have 1 decimal place. And you'll notice that we cut off the answer right here, based on the least 1. So because the least came from this first number, we'll cut it off at the end right here. You still do the addition. Notice the 8, again, rounded up to a 9. So we'll have to use rounding rules. So hopefully that makes sense. If this were a subtraction, the same exact idea would hold. Let me actually show you something with this. That one little note. You'll notice that if we go by the total number, notice here we have a total number of 3 significant figures. But notice that our answer has a total number of 4 significant figures. So we do not go by total number of significant figures when you're adding and subtracting. We go by the least number of decimal places. Hopefully that makes sense. A quick little note about rounding. Rounding is really simple. You've probably heard about this before. If the number is followed by a 5, 6, 7, 8, or 9, so essentially 5 or greater, you round up. And if it's 4 or less, you round down. So you've done this before, you've rounded before. Hopefully this makes sense. So let's do an example problem, and then I'll let you do a practice problem on your own. In this example problem, we do an operation, and then we ask how many numbers should we round to. So notice here, we're beginning with division. Division said you go by the total number of significant figures. So this first number has how many? 3. Second number has 4. We'll go by the least, so we've got to round it down to 3, which means we will cut it off right here. So our answer is actually 18.9. Would be our final answer. Only 3 significant figures. When we're multiplying, same idea. We go by the least. Now, this number has 3. This number has 2. Remember, this 0 is significant because it's a final 0. It comes after a decimal, after a number. So our answer should have 2. Now, this is going to be a little tricky. If you try to round this down to 2 significant figures, a lot of students will try to just cut it off here and make this a 33. And this would be incorrect. It's incorrect because your number here is 332. So if you had $330 and somebody said, well, let's make it a little more significant, I'll give you $33, you'd be pretty upset. We cannot change the value. In fact, what we have to do is we have to make this 2 into a 0. And that will make 2 significant figures. So your final answer here is actually 330. So with a big number like this, if you want to reduce significant figures, you just make zeros in the end. Remember, this 0 is not significant because there's no decimal place. So this is your final answer, 330. Do not put the decimal place there. All right, let's keep going. Here we have addition. With addition, we go by the least number of decimal places. So here we have 2 decimal places. Here we have 4 decimal places. So our answer should have only 2 decimal places. So we'll cut off the answer right here. Now the 7 will round the 1 up to a 2, and your final answer is 4.32. That would be your final answer. And then finally, we've got subtraction. Again, we go by the least number of decimal places. This number has 3 decimal places. This number has only 1 decimal place. So your answer should only have 1 decimal place. So we'll round this down to, or rather up to 12.2. The 5 again rounds the 1 up to a 2. Make sure you do the round. So hopefully that makes sense. Go ahead and try practice problem 4 on your own, and that completes video 4.